Sir, doubt in few questions of the assignment.
Okay, what are the doubts?
Sir, doubt in question 10th, question 11th, and question 17. So this is the question. If 2 liters of N2 is mixed with 2 liters of H2 at a constant temperature and pressure, then what will be the volume of NH3 formed?
Right. So the formula, sorry, the equation for that one is that N2 plus 3H2 will give you 2NH3. So for that, you need to know the balanced equation.
So now we can decide which one is the limiting reagent.
Yes, exactly.
Q and R ratio on the basis of liters.
Right. So here, on the basis of liters, because this is liter, you can consider these as moles. Molar ratio and volume ratio at same temperature and pressure will be same. Okay. So as per the reaction, 1 mole or 1 liter of N2 will react with 3 liters of hydrogen, and when they combine, completely consumed both, they will produce 2 liters of ammonia. Now I told you a trick to find out the limiting reagent. What was that trick?
Q by R.
Q divided by R. Okay. So this is the required in the reaction, and this is given in the question. So Q is 2 liters, 2 liters. Calculate Q by R ratio 2 by 1, 2 by 3. Which one is less? 2 by 3 is less. This is the limiting reagent. This will decide how much ammonia will be produced. Now, if you see 3 liters of hydrogen produces 2 liter. So 2 liter will produce 2 by 3 into 2. That is 4 by 3 liters. In question, what was asked? Amount or liters.
Volume of NH3.
Okay. That will be the answer.
Sir?
Yes.
Sir, I have submitted, sir. Just 10 minutes ago, I submitted. Sir, actually, yesterday I was not at home, so that's why I was not able to submit.
Lakshya. Okay, I'll check whether you have submitted.
Yes, sir. Yes, sir.
Sir, I have also submitted now.
Lemuel, you have submitted?
Yes, sir.
Okay, that's good. You had anyway promised that you will submit. I had got your message, but I have written the names of only those persons, those students who did not attempt, who did not submit the assignment, and also did not ask their parents to send the message to me. Yes, what was the confusion and any other doubt in previous assignment?
Sir, can you please tell the question 12?
What is question number 12? Because I don't have assignment in front of me.
Yes, sir. Yes, sir. Sir, I am just opening it.
So can I tell the question?
Yes.
Sir, the question is 0.5 mole each of H2S and SO2 mixed together in a reaction flask react together to equation 2H2S plus SO2 that will give 2H2O plus 3S. Calculate the number of moles of S formed.
So you have 0.5 moles of, so this is as per the question. Okay? 0.5 moles SO2, 0.5 moles H2S. And according to reaction, 2 moles of H2S react with 1 mole of, this is the stoichiometric ratio. 2 moles react with 1 mole and they produce 3 moles of alcohol. So have the Q by R ratio 0.5 by 2, 0.5 by 1. So this one 0.5 by 2 will be 0.25. This will be 0.5. Obviously, this is less. H2S is the limiting reagent. Is this moles or grams? 0.5. Moles given?
Moles.
Yes, sir. Mole.
Then H2S is the limiting reagent. And now see what is the ratio to the reaction ratio. Okay? Always reaction ratio will decide. 2 moles of H2S give 3 moles of sulfur. So these many what you have 0.5, 0.5 will give how many? Because limiting reagent will decide how much product. will be
0.75.
Okay, so it will be from here, 1 mole will react by 3 by 2 into 0.5.
Yes.
So 1.5 divided by 2, 0.75 moles. So you can convert 0.75 moles to grams also. If it is asked amount, you can write either 0.75 mole or 0.75 into 32 grams, which will be 24 grams.
So can you please explain question 14 as well?
Just a second. Just a second. I'm getting a call. Just few seconds. Okay. Yes. What is question number 16?
So 14. So just a minute, I'm telling. So the question is, calculate the mass of ferric oxide that will be obtained by complete oxidation of 2 gram of Fe.
Okay. So 2 gram of Fe.
Yes, iron is right.
It is just written Fe or it is written FeO? Read the
The
question.
Fe.
Sir, Fe.
So it will be 2 Fe plus 3 by 2 O2 will give you Fe2O3. Okay. You have
Yes.
the balanced reaction here. Okay. How much iron is there?
4 grams.
4 grams.
2 grams.
2 grams. Okay.
So 2 gram.
2 grams. Right. Now iron's atomic mass is 56. Okay. So you can do calculation in grams, you can do calculation in moles. So this is what is given in the question. Now, according to the reaction, 2 into 56, 2 moles, 2 into 56, 2 into atomic mass grams will provide 2 into 56 plus 3 into 16. Is that clear or not?
Yes.
Okay,
Yes,
iron's
sir.
atomic mass is 56, but we have 2 moles, so we multiplied by 2. Here, its molar mass will be 2 into 56 plus 3 into 16. Hence, 2 gram will provide 2 into 56 will be 112 and 48, 160. So it is 160. 2 gram will provide 160 by 112. Erased everything. So 2 according to the question, 2 grams according to reaction, 2 into 56, that is 112 grams, will produce 160 grams. Molar mass of Fe2O3 I had already calculated. 2 into 56 plus 3 into 60. So if 112 gives 160 gram, 2 grams will give 160 by 112 into 2 grams. Simplify this one, get the answer. Is that clear? Because in the question it is written complete oxidation, means entire 2 grams will be consumed.
Yes.
Sir?
Yes.
Sir, I actually had a doubt in question 7 also. Sir, in which we have to round off the figures up to 3 significant figures. And sir, the number was sir 2808.
2808. You have to round off till, now this has 3. You have to round off till 3. So you will write
Yes, sir.
2810, because if you remove 8, this will become 1. And this has 3
Yes,
significant
sir.
figures.
Yes,
This
sir.
0 will not be considered because it is towards right, but not after the decimal,
Yes, sir. Yes, sir.
right? Any
Yes,
other
sir. Yes, I
question?
got it.
Got it? Okay. Any other doubt in previous assignment?
The last question.
What is that question?
Sir, I have a doubt in
Yeah.
question number 19 also. Sir, can I WhatsApp you the question, sir?
Yes, you can WhatsApp, or let me, I can open. Which question? Someone said question number 9.
Sir, question number 19, sir.
Okay.
Answer 20th also. That is the last question. 20th.
First, I'm doing question number 19. Question number 19 is an organometallic compound on analysis was found to contain carbon this much, hydrogen this one, iron this one, this much. Why we call it organometallic? Because it is organic compound and has metal iron. So that's why. Otherwise, there is no significance of organometallic. Okay, determine its empirical formula. So to determine, because it is written, it is 64.4%. First you will add and see whether it is approximately 100% or not. So carbon, hydrogen, and iron. Carbon is given 64.4%. Hydrogen is given 5.5%, and iron is given 29.9%. If you just add these, do you get approximately 100?
Yes, sir.
Okay. Yes, you get approximately 100%. It means the rest you will not consider as oxygen. 99.8 is approximately 100%. It means only these 3 compounds are there. So I will be doing a similar question today, so that will be more clear. So from here, you know that atomic mass of carbon is 12, hydrogen 1, iron 56. So divide to get the moles. Mole will be given mass divided by atomic mass. Given mass divided by atomic mass. Given mass divided by atomic mass. So whatever value you get after that, you will simplify. You will get the answer. So for example, here if I see 12 fives are 60 and
5.36.
Sir, it will be 5.3.
approximately. Yeah. Okay. So 3 approximately. It is 5.5, and this one will be
0.5.
0.53.
0.
approximately this one, isn't it?
Yes,
So
sir.
if you divide everything by 0.55, you will get the simplest ratio. So first 2 digits are approximately 55 in all cases. So divide all 5.33 divided by 0.55,
Sir,
5.5,
10.6.
0.55, 0.55 divided by 0.55. So it means it will be 10.
Sir, 10.6.
10.11.
It will be,
Sir,
This will also be
10.3.
10, sir.
it will again be 10.
10, 10, 1.
Oh,
And sir, that will be 1. Last one.
Yes. So C10, H10, or F.
Yes.
This will be the compound. Okay. If these are the percentages. Yes. Similar question we will be doing today. So concept will be clear.
Sir, I've sent you the last question on the WhatsApp.
What is the question? Because now I have, it is 20th question.
Yes.
How many grams of Cl2 are required to completely react with 0.4 grams of hydrogen to yield HCl? Also calculate the amount of HCl formed. Okay. So again, limiting reagent question. So it is chlorine and hydrogen react to produce HCl according to this reaction. means the reaction ratio is 1 mole requires, hydrogen requires 1 mole of chlorine, and when they are consumed completely, they produce 2 moles of hydrogen chloride. But what is given in the question, you have 0.4 gram of hydrogen. Okay, so in the reaction also, instead of moles, convert these to grams. So hydrogen molar mass is 2, it will be 2 grams. Chlorine 35.5 into 2,
71.
71. And this will be obviously the sum of these two, 73 grams, according to law of conservation of mass. 2 into 36.5, 73. Okay, so now this is the required, and this is what you have. So you will see the ratio from required. 2 grams of hydrogen produce 73 grams of HCl. As 2 grams of hydrogen produce HCl equals to 73 grams. Hence, 1 gram will produce 73 by 2 and 0.4 gram. It is asked how much 0.4 gram will, that will be 73 by 2 into 0.4 to 0.2.
14.6 grams, sir. I think. Sir, I think the answer is 14.
14.6 approximately, that will be the answer.
Yes, sir.
Grams. Now the second part is also calculate the amount of HCl formed with, that is what is asked. Okay. The first was how many grams of chlorine are required. Okay, this was the second part actually. The first part was
Yes,
how many grams of chlorine are required. So again, now apply the logic here, relationship here. So say as 2 grams hydrogen react with, now don't write produce with, they react with 71 grams of Cl2, hence 0.4 gram. H2 will react with 71 by 2 into 0.4. So here you will get 14.2 grams. So 14.2 grams chlorine. So first part answer will be 14.2. Second part answer will be 14.6 grams of HCl. Is that clear?
Yes, sir.
Yes.
Okay, good. Now moving to questions based on molarity, etc. Concentrations basically.
Sir,
Very
can
good.
you discuss question number 15?
Question number 15. Have you submitted the assignment?
Yes, sir.
Okay, a sample of drinking water was found to be severely contaminated with chloroform, supposed to be carcinogenic in nature. The level of contamination was 15 ppm by mass. Express this in percent by mass. So ppm is actually ppm.
Parts per million.
Parts per million.
That is in 1 million. How much you have? So 15 ppm means in 1 million particles. Okay, because it is written by mass, you will write grams. In the question, it is written in bracket by mass, so you will write grams of water contain 15 grams. This is what 15 ppm means, 15 parts per million. So 15 grams in 1 million grams of water. So if this condition is given and you are asked, express this in percent, and in percent out of what amount you calculate? You calculate out of 100. So hence in 100 grams, it will be 15 by 10 to the power 6 into 100. Unitary method I am applying. Means 15 into 10 to the power 2, 100 is 10 to the power 2, and 10 to the power 6 when in numerator 10 to the power minus 6. That is 15 into 10 power minus 4. That is 1.5 into 10 to the power minus 3 grams. Sorry, percentage here it will be. Because here it is in 100 gram. Percentage has been asked, so write percentage. Is that clear? Concept
sir.
of ppm, right? Second part, determine the molality of chloroform in the water. To calculate the molality, the formula is you need a number of moles of chloroform. So you know 15 grams of CaCl3. From here you can calculate moles of CaCl3 will be equal to mass divided by molar mass. Molar mass of CHCl3 will be 12 plus 1 plus 3 times 35.5.
So it was 119.5.
119.5, yes.
Yes.
Good. So these many moles you have. Now in this case, 10 to the power 6 grams of water as compared to this 15 gram is negligible. 15 gram is negligible as compared to 1 million. So you have these many grams and you have 15 grams. So you can ignore this one. So whatever is the mass of solution will be approximately the mass of solvent. Why I am telling you? Because in molality, it is number of moles of solute divided by mass of solvent in kg. So here you can ignore 15 gram. It is just negligible amount. So whatever is the mass of solution, you will consider mass of solvent. So if you apply the formula, you will say molality will be equal to number of moles which you have calculated from here, 15 divided by 119.5 divided by mass of solvent in water. Now this one is in gram. You need to convert it to kilogram. So when you convert it to kilogram, 10 to the power 6 divided by 10 to the power 3. Whatever you get, that will be the answer. So approximately, if I see, this one can be
1.255 into 10 to the power minus 4 mole
yes,
per kg.
right. Because it is just 120 approximately, and if you divide 15 by 12, you will get approximately 1.25. Okay, so it will be 1.25 approximately into 10 to the power, because it is 120, not 100, not just 12. So there will be one more 10 to the power minus 1. So 10 power minus 4, not 10 power minus 3. Then have the unit, right? Either you write a small m or you write mole per kg. Is that clear?
So why did you do 10 raised to the power 6 divided by 10 raised to the power 3?
Because mass of solvent here is taken in kilograms in the formula. And here you have 1 million grams. You changed grams to kilograms.
Oh,
How 1 million grams will be 1 million divided by 1000 kilograms. That's why I did 10 power 6 divided by 10 power 3. So I hope now all the questions of previous assignments you would be able to do.
Yes, sir.
Right. Good. So 1 mole, you know, the modern definition is in terms of particles. More close to what Avogadro said. Okay. So this is Avogadro number. So 1 mole of any substance, anything, whether it is chemistry or not, 1 mole will have 6.022 into 10 power 23 particles. Now this is something I covered in detail, but here I will be covering just very quickly. 1 mole you can represent in terms of particles, in terms of volume, if all are gases, and in terms of mass. If we consider in terms of particles, when I say representative particles, means whether it is molecule or ion or atom, whatever it is. So representative particle means if we are talking about to say HCl, then we will say these many particles, these particles are molecules. If we are talking about, say, just carbon, we will say it is atom. If we are talking about moles of sodium ion, we will say this is ion. If we convert mole to the particles, we will multiply moles by Avogadro number 6.022 into 10 to the power 23. Okay. So remember, whenever we are moving outward, it will be multiplication. Whether it is particles, whether it is volume, whether it is mass, it will always be multiplication. And opposite will be division. Whatever you have here, divided by n, 6.022 into 10 power 23. So when you are going outward, multiply by same thing. You are going inward, divide that by that thing. Here that thing is Na, Avogadro number. Similarly to volume of gas, and this is applicable only for gas and STP. Okay, at STP, standard temperature and pressure, 0 degrees Celsius, 1 atmospheric pressure. So when you are moving outward, you are converting mole to equivalent volume. You will multiply it by 22.4. You will multiply what you have moles, you will multiply mole by 22.4. When you are coming back from volume to mole, now what you have volume. So divide volume by 22.4. Similarly, when you are converting mole to mass, so when you are going outward, you will multiply this mole by molar mass. You have mole, multiply by molar mass. And when you are going backward, what you have mass. So divide this mass by molar mass.
Sir, I have a question.
Yes.
So instead of STP, if two gases are under the same temperature and pressure, but it is not STP, so then will they have the same volume?
No, they will not have the same volume. No, they will not have. No, they will not have the same volume, and that is something we will be talking about in 5th chapter, states of matter. Okay. And in physics, you might have gone through, P1 V1 by T1 equals to P2 V2 by T2, or at least PV equals to nRT. Have you gone through that equation? If not, then we will be talking about that in 5th chapter. Then it will be clear that at any other temperature, the volume will be different.
Okay, sir.
The conditions are not same. And you can understand it. For example, if you heat some gas, it will expand. So if you increase the temperature, gas will expand, it will acquire more volume. So that's why temperature and pressure have to be constant.
Okay, sir.
Now, in a broad sense, what we can say that 1 mole of an element is equal to its atomic mass in gram. So if I say I have 1 mole of an element, say carbon, so it will be equal to 12 gram. Atomic mass is 12. So 1 mole of carbon will be equal to 12 gram. Element I am talking about. Okay. So for example, if I have 1 mole of iron, atomic mass of iron is 56. It means if I have 56 grams of iron, I will say it is 1 mole. And here it will have 6.022 into 10 to the power 23 atoms of carbon. This will also have 6.022 into 10 to the power 23, but atoms of iron. Okay. 1 mole will always have 6.022 into 10 to the power 23 particles. Now, if instead of element we have compound, then in case of compound, we consider molecular mass. For example, here if I have sodium element, I'll say its atomic mass is 23. And say if I have sodium chloride, then I'll consider molecular mass. I'll say 23 plus 35.5, that is 58.5. So this is molar mass. This was atomic mass. 1 mole of a compound will be equal to its molar mass in grams. So add all atomic masses with their obviously ratios. So why I say with their ratios? For example, instead of 1 Na, 1 Cl, I can have CO2. So here I will say 12 plus 2 into 16. That is 44 grams will be equal to 1 mole in simple terms. Now, very important point where students make mistake. 1 mole is also written as gram atomic mass, means atomic mass represented in grams. Gram atomic mass. Gram atomic mass does not mean that you have to represent it in grams. No, it will be 1 mole. It is actually mole. Similarly, if you are asked to calculate gram molecular mass, it will be 1 mole of a compound which exists in the form of molecules. 1 mole is also called gram molecular mass, means molecular mass represented in grams. So don't answer in terms of grams, answer in terms of moles if gram atomic mass or gram molecular mass is asked. Now, when I say that 1 mole is equal to the atomic mass or molecular mass in grams, so for example, mercury oxide, if I talk about, so mercury oxide, if I say 2, it will be equal to HgO. And when I add the atomic masses of mercury and oxygen, that is 200.59 plus 16, I will get 216.59. So its molecular mass is 216.59. It means those many grams will be equal to 1 mole. Similarly, if I have sucrose and I say how much of sucrose will be 1 mole, sucrose formula is C12H22O11. When you calculate its molecular mass, it will come out to be 342. Okay, U. Okay. Molecular mass, I'm not saying molar mass. Okay. Molar mass will be 342 grams per mole. Its molar mass represented in grams. So 342 grams of sucrose will be equal to 1 mole. Why? Because its molar mass is 342. Similarly, sulfur, and sulfur is tricky one because sulfur does not exist as S, it exists as S8. So if it exists as 8, its molecular mass will be 8 multiplied by 32, 256. It means 256 grams of sulfur will be equal to 1 mole. And when I am talking about 1 mole, whether the quantity is more or less, all will have 6.022 into 10 power 23 particles. All shown here will have exactly same number of particles because these are 1 mole. Similarly, copper 2 sulfate pentahydrate. When I say copper 2 sulfate pentahydrate, it will be CuSO4.5H2O. Pentahydrate means 5 water molecule of crystallization are attached to it. So when you add all these, okay, copper 63.5 plus sulfur 32 plus 4 times 16 plus 5 times 18, water molecular mass is 18. When you add all these, you will get 249.50. It means 249.50 is its molecular mass. These many grams will be equal to 1 mole. Similarly, sodium chloride, NaCl. NaCl, I have already told you 23 plus 35.5, 58.5. Copper atomic mass is 63.5. I used it here. So 63.5 atomic mass, 63.5 will be equal to 1 mole. Is there any confusion? Just let me know because this should be very much clear. The relationship between the mass and mole is just by atomic mass or molecular mass, depending on whether the compound exists in the form of element or it exists in the form of molecules. Everyone clear that?
Sir, I have a doubt.
Yes.
So
Yes.
if suppose some element like sulfur does not exist as an atom in nature, so in a question, would we always consider S8 or would we just consider sulfur? Like in a question of mole concept, would we take molecules?
Good question. Very good question, right? In questions, it will depend on the balance reaction. In question, it will always depend on the balance reaction. So for example, in one of the questions we did today, it was 2H2S plus SO2 give you H2O plus 3S. So you will
Yes.
not consider there S8 because S is written there. You will consider exactly whatever is written there.
Okay, sir.
Okay. Here I am talking about if we have sulfur, okay, in a beaker, then we will consider it as S8 because that's how it exists. But in the reaction, only 3 moles are taking part, and that 2 atomic moles. Okay, so whatever is written in the reaction, you will consider that thing.
Okay, sir.
Right. Now the question, what volume is occupied at STP by 1.4 gram of nitrogen? Atomic mass of nitrogen is given as 14. So see what is the relationship. Relationship is between volume and mass. It means in all such questions, it is between volume and mass. It means you have to come from here to here or from here to here, depending on what is asked. So in this question, what is asked, what is given, first see what volume is asked and mass is given. So mass 1.4 gram given and volume is asked. So you will move from mass to mole and mole to volume. This will be the path. It is given 1.4 and it is nitrogen. Okay, it is nitrogen. So 1.4 grams of nitrogen. To convert that to mole, you will divide mass divided by molar mass of nitrogen, and molar mass of nitrogen is N2, that is 2 into 14, 28. So you will divide it by 28, not by 14, because nitrogen does not exist like N. So when we are not talking about reaction, we will always use how it exists. Here we are not talking about reaction. Here we are talking about conversion from mass to mole. We will always consider how it exists. So we got 1.4 divided by 28 moles. Now to convert these moles to volume, you will multiply these moles by 22.4. 1.4 divided by 28 multiply by 22.4. That will be the answer. Any confusion, let me know. Now because
No, sir, no.
22.4 is slightly less than 28, so this fraction will be less than 1. It means the answer will be slightly less than 1.4. It should be approximately 1.2, 1.1 approximately when you calculate. Don't hesitate if you have still any confusion. So you will get 1.12 liters. How you will write? First, from mass to volume. You will say moles of nitrogen will be equal to mass divided by molar mass, mass divided by molar mass. These many moles you have. Volume will be equal to number of moles multiplied by 22.4. 1.4 divided by 28 into 22.4 equals to 1.12 liters. Next, one atom of an element X weighs 6.644 into 10 power minus 23 gram. Calculate the number of gram atoms in 80 kilograms of it. Now this one is very easy question if you know the concept. Weight of
Yes,
one
so 1
atom
mole
is
is equals to 1
right.
mole is equal to 6.022.
Come again, 1 mole
Is equal to 6.022 into 10 to the power 23 atoms.
Yes, that's what you need to consider, because mass of one atom is given. Mass of 6.022 into 10 power 23 atoms will be equal to molar mass. What is molar mass? Molar mass is mass of 6.022 into 10 power 23 atoms. Why I am writing atoms? Because here it is element, atom of element. So mass of these many atoms will be equal to mass of one atom into 6.022 into 10 power 23. That is 6.644 into 10 power minus 23 into 6.022 into 10 power 23. These two got cancelled. When you multiply these two, you will approximately get 40. Approximately. 6 6 will be 36. Then again 6 6 will be 36, 3.6. Then again 4 6 24, so approximately 40. How I do such calculations? First I do 6 6 36. Then 6 6 36. Then 4 6 24. So that's how get it quickly. Okay. 4 8 9 3 39.84 means approximately 40. So the moment I got the molar mass as 40 gram per mole, I can calculate the gram atoms. What is gram atoms? Who will tell me? Raise your hand, raise your hand, raise your hand, raise your hand. Don't say anything. Okay, Yash, Bedi.
The number of moles.
Okay, good. Gram atoms, number of moles. We talked about it. Whenever you see this term gram atom, don't think it is gram. It is number of moles. Yes.
So instead of multiplying 6.644 into 10 to the power minus 23 from the Avogadro's number, could we have just converted it into AMU instead?
What do you mean? Just elaborate with that.
So like the mass of an atom is measured in AMU, right? Not in grams.
In that case, you will not mention it molar mass. For example, I have used the unit gram per mole. You can do that. But here you will mention it as 40 U. That will be the difference. It will come out to be 40, sir. But you will use unit.
We'll just express 14 grams to get.
Yeah, you can do that. Okay.
Okay, sir.
So because you have the molar mass and you have the mass also, so number of moles, gram atoms means moles, will be equal to mass divided by molar mass. Mass is 80 kilograms, so don't get confused and don't forget to convert it to grams. This mass is always in grams. Divided by molar mass, 40 grams per mole means it will be approximately 2000 moles. Yeah. Here in answer it is written gram atoms because gram atoms was asked. So that's why it is better to write gram atoms instead of moles, although both are same. Next one. The cost of table salt is 12 rupees per kilogram. Calculate cost per mole. So it is just very simple question that you first need to calculate how many grams will be there in 1 mole. So 1 mole of NaCl, what is asked? Cost per mole. So if we get how many grams are there, it will be equal to its molar mass in grams. Molar mass will be 23 plus 35.8. That is 35.5, 58.5 grams per mole. Now you will apply unitary method that for 1 kg cost is 12 rupees. Hence for 58.5 grams, how much will be the cost? So 1 kg means 1000 grams. As 1000 grams of NaCl costs 12 rupees. Okay. Hence 1 gram will cost 12 by 1000. Hence 58.5 grams will cost 12 by 1000 into 58.5. Whatever you get as the answer. 58 into 12 will be approximately 600 something. So it will be, yes, 70 paise.
Yes, so 70.2 paise.
Yes, 12 6, if this digit would have been 6, then 12 6 would have been 72. It is slightly less than 60. It will be 70 paise. Remember, you will get answer in rupees. This answer will be in rupees. Here it is written in paise. It means you need to multiply that by 100. then you will get 70. This answer will be in rupees. You will get 70 approximately rupees, which will be equal to 70 paise. Next, calculate the weight of carbon monoxide having same number of oxygen atoms as are present in 88 gram of carbon dioxide. These type of questions are very common. Okay, similar questions. Two compounds will be given and any one elements ratio will be either same or maybe 2:3, 1:2, whatever. Okay. So in this question, the question is calculate the weight of carbon monoxide which has same number of oxygen atoms as there are in 88 grams of carbon dioxide. Now remember, the ratio of atoms can be termed in terms of ratio of moles also. Okay. So here, what is the ratio? There are two ways to handle these type of questions. Okay. If you are confident enough, you can deal it in moles instead of atoms, and you will get the answer. But if you don't have high level confidence, then deal with the atoms only. So first I am doing with the atoms. So 88 grams of carbon dioxide will have how many atoms? 88 gram actually will be equal to how many moles? Given mass divided by molar mass, 2 moles. Okay. And 1 mole, 2 moles of carbon dioxide. 1 mole of CO2 has how many moles of oxygen atom? We have to get oxygen atom. 2 moles.
So 2 moles
of oxygen atoms. Okay. It means 2 moles of carbon dioxide will have 4 moles of oxygen atoms.
Yes, sir.
Okay. And 4 moles, these 4 moles of oxygen atoms will have 4 into 6.022 into 10 power 23 atoms of oxygen. 1 mole is equal to 6.022 into 10 power 23 atoms. 4 moles will have 4 into 6.022 into 10 power 23 atoms. It means this carbon dioxide should have these many atoms. Now in carbon dioxide, what is the ratio between atoms and moles? Okay. Now we have to get weight. That's why I'm talking about in terms of moles. 1 atom of oxygen is in 1 molecule of carbon monoxide. In 1 molecule of carbon monoxide, there is 1 atom. So why I am doing from 1 oxygen atom to molecule? Because I have to get moles of carbon monoxide. That's hence whatever is given here, 4 into 6.022 into 10 power 23 atoms will be in 4 into 6.022 into 10 power 23 molecules of carbon monoxide. So from 88 grams of carbon dioxide, I got the oxygen atoms. Same oxygen atoms I considered here. And from those oxygen atoms, I got how many molecules of carbon monoxide will be there. It will correspond to 4 into 6.022 into 10 power 23 molecules. From here, I can convert number of particles to mole. How I convert number of particles to mole? This is the
so
way.
dividing by Na.
Divide by this part. Divide by Na. So if I divide it by Na, I will get moles of carbon monoxide 4 into 6.022 into 10 power 23 divided by 6.022 into 10 power 23. These got cancelled. I got 4 moles. And 4 moles of CO will be equal to 4 into its molar mass in grams to get grams. Okay, how many grams will be there in 4 moles? Number of moles multiplied by molar mass. That is 4 into molar mass of carbon monoxide will be 12. into 32. Sorry, 12 into 16, that is 28. Multiplied by 28. 4 into 28 will give you 20, 30 into 4 is 100. 30 into 4 would have been 120. 2 into 4, 8. 120 minus 8, 112. That is the answer. So the calculation, yes, there is a lot of calculation, but otherwise the concept is very simple. What we have done, we have to have same number of oxygen atoms in carbon monoxide as there are in CO2. We calculated oxygen atoms in CO2 and we had same number of oxygen atoms in CO. And then from same number of oxygen atoms, what is the ratio of oxygen and carbon monoxide? Carbon monoxide and oxygen atom 1:1. One molecule of carbon monoxide contains one atom. So whatever you have as the number of oxygen atoms, same will be molecules of Cu. Is that clear? Any confusion, any step is not clear, let me know.
Sure, but we can do this rather easily now by just taking ratios.
Yes, that's what the second way I'm coming to. So first is when you consider whatever is written in the question, it is written oxygen atoms, you are considering it just oxygen atom. Now, if you consider it in terms of moles, obviously oxygen atoms we will consider. Then compare these two. CO2, CO. Okay, 1 mole of carbon dioxide has 2 moles of oxygen atoms. Here 1 mole of carbon monoxide has 1 mole of oxygen atom. It means effectively what we are saying in terms of oxygen atoms, okay, 1 carbon dioxide will correspond to 2 CO. The ratio is you will have 1 carbon dioxide will lead to 2 carbon monoxide because here you have 2 atoms. 2 atoms here will be in 2 molecules. So it means whatever molecules or moles you have of CO2, the number of moles or molecules will be double of that. So if you calculate, so you will say 1 CO2, sorry, I will have to just reconnect just a second. You can say 1 mole of CO2 will correspond to 2 moles of CO in this case. If you are having same number of oxygen atoms. So 1 mole of CO2 will have 2 oxygen atoms and 2 moles of carbon monoxide will have 2 oxygen atoms, same number of oxygen atoms. And how many moles here you have in 88 grams? In 88 grams, CO2 is equal to 88 divided by 44. That is 2 moles. It means it will correspond to 4 moles of CO2. Sorry, CO. Just double. Ratio is 1:2. So if you have 4 moles of CO2, it will be 4 into its molar mass, 112 grams. 88 grams of CO2 will correspond to 112 grams of CO. Then they will have same number of oxygen atoms. Is that clear? So here I am not going in details of the atoms, rather I am doing from moles to moles. No, in this case, law of multiple proportion will not be used. Rather, it is simple ratio of moles if oxygens are same. Samat. Any confusion, let me know.
No, sir. No confusion.
Now, stoichiometric ratio, whatever we are talking about, whenever we talk about any balanced reaction, that is actually stoichiometric ratio, and that is stoichiometry. So when I say, for example, um, the common example we take as N2, because it has 2, 3, 1, all the ratios. So I think the best example. The production of ammonia, when you combine nitrogen and hydrogen, it says that if we talk about in moles, it says 1 mole of nitrogen will react with 3 moles of hydrogen, and when they are consumed completely, they will produce 2 moles of ammonia. Remember, these 2 moles will appear when these are not there. Okay, so initially say this is the molar ratio 0 here. When these are consumed completely, there is no nitrogen or hydrogen left, then you will have 2 moles of ammonia. So these are called stoichiometric ratio. 1, 2, 3. Molar ratios are stoichiometric ratio. Now same thing, instead of moles, you can say 1 mole of nitrogen reacts with 3 moles of hydrogen, and when they are consumed completely, they produce 2 into its molar mass. Okay, 17. That is 34 grams of ammonia. So this is another statement which is stoichiometry, that 1 mole of nitrogen produces 34 grams of ammonia. Or you can say 1 mole of nitrogen is actually equal to 28 grams. You can say 28 grams of nitrogen react with 3 moles of hydrogen, means 3 into 2, molar mass 2, that is 6 grams. React with 6 grams of hydrogen, and when they are consumed completely, they produce 34 grams of ammonia. Or you can talk in terms of volumes. If at STP we are talking about, this is 1 mole. 1 mole will be equal to 22.4 liters. And this is 2 moles. 2 moles will be equal to 2 into 22.4, means 44.8 liters. So another stoichiometric statement will be that 22.4 liters of nitrogen react with 6 grams of hydrogen and produce 44.8 grams liters of ammonia.
Of NH.
So you can have all the quantities, whether in liters, whether in moles, whether in grams, or in particles. Okay. So in another way, you can say that 22.4 liters nitrogen produce 2 moles into 6.022 into 10 power 23 molecules, means 12.044 into 10 power 23 molecules of ammonia. So whichever way you want to represent, this is called stoichiometry. Playing with their ratios in terms of moles, volume, mass, particles, whichever way you want to represent it, that is called stoichiometry. And these are called stoichiometric ratios. When we talk stoichiometric ratios, then they must be in same quantity. Okay, all should be moles, or all should be volumes, or all should be particles. In case of a stoichiometric ratio, we will not consider mass because that will change the ratio. Ratio will always be in terms of moles, volumes, or particles if we are talking about stoichiometric ratio. Next, mass percent. This mass percent is different from the mass percent we will be talking about solution. This is we are talking about mass percent in a compound. So if suppose I have Na2CO3, I say what is the mass percent of sodium? So mass percent of sodium, for that I will see what is the molar mass, how molar mass is written here. Molar mass will be written as 2 into 23, this part, plus 12 plus 3 into 16. So if I say what will be the mass percent of sodium, I will take this part in the numerator and this 4 in the denominator. That's it. Means in this case, if I say mass percent of sodium, it will be equal to 2 into 23 divided by complete, whatever. But suppose I say molar mass of mass percent of carbon, I will not consider this one, rather I'll consider this as here. So I will have 12 divided by total. If I am talking about mass percent of oxygen, it will actually be 3 into 16, 48 divided by total. Then, because we are talking about percentage. Empirical and molecular formula. I hope empirical and molecular formula, one question we have already done. So empirical formula is the simplest whole number ratio of atoms present in the compound. Simplest whole ratio of atoms. This is very important. Students make mistake here, despite me telling every time. It is ratio of atoms only. So don't consider O2, N2. Sometimes you consider O2 or N2. No, you will always consider O, N, C, H, atomic forms only when you are calculating the ratio. The molecular formula is the exact number of different types of atoms present in molecule. So it is molecular formula is exact. For example, CH is empirical formula of ethyne, C2H2 is exact formula. The exact formula is molecular formula. Okay. Similarly, empirical formula has exact molecular formula C6H6 also benzene.
And so there's one more formula, sir. The number of molecules that is equals to empirical formula mass upon molecular formula.
That is how you convert empirical formula to molecular formula. Okay. So
Yes.
the factor by which an empirical formula needs to be multiplied to get molecular formula is given by molecular formula mass divided by empirical formula mass. Okay. So for example, this N factor, if I have been given benzene, so mass, molecular formula mass of C6H6 divided by CH, so obviously it will be 6. Okay. So suppose it is given that the molecular mass, it is given suppose. Empirical formula you have calculated as CH, okay, and molecular formula mass is given 78U. Okay. So you will calculate it as 78 divided by empirical formula mass 12 plus 1, 13. Okay. then it will be 6. It is 6, so you will multiply CH by 6 and you will get C6S. Now, very quickly, this question I will be doing. Percentages of hydrogen, carbon, and chlorine are given. Molecular formula mass is also given. You have to calculate empirical as well as molecular formula. I suggest that you use the table to solve such questions. Although you can get whatever I have written in the table, I will show you. You can write in sentences also. Okay. So carbon, hydrogen, chlorine, you will write. Then you will write the formula, percentage composition, atomic mass, moles of atoms, then molar ratio. And if required, you will have last column as simplest molar ratio. If this ratio does not come out to be simplest in that case. So percentage compositions are given 24.27, 4.07, 71.68. You need to get moles, and how you get moles? You get moles from given mass upon molecular mass. So what you consider that we have 100 grams of the compound. If you have 100 grams of compound, these percentages will actually get converted to grams. Out of 100 gram, 24.27 grams. And then you will calculate, find the atomic mass, 12, carbon, hydrogen is 1, chlorine is 35.5. To get the number of moles of atoms, yeah, always atoms. So you will divide. Given mass divided by molar mass, given mass divided by atomic mass, given mass divided by atomic mass. All these are always atomic masses. So you got some values. Simplest ratio will be you divide by the minimum one. Minimum one is 2.02. Ratio will be 1:2:1. Hence the empirical formula will be C1H2Cl1. One you don't write, so it will be CH2Cl. Then you will calculate empirical formula mass. Empirical formula mass, because it is CH2Cl, it will be 12 plus 2 into 1 plus 35.5. So 12 plus 2, 14 plus 35 point means 49.5 U. 49.5 U number by which, the factor by which you need to multiply will be molar mass, which is given 98.96 divided by empirical formula mass, which will be approximately 2. It means you have to multiply this empirical formula by 2 to get the molecular formula. So molecular formula will be C2H4.
C2H4Cl.
Yeah. That is the answer. Any confusion here in this question?
No.
Okay, good. So because still we are not able, we have not done the complete revision. Okay, there are quite a few good questions which I had to do today, probably due to the questions we did in the beginning, the doubts in the assignment. So that is something because I think many students have UT on Monday. So what I'll do, I'll schedule half an hour session of this one and 1.5 hour session for JEE aspirants. So the time I will be sending maybe today evening or tomorrow morning. Most probably it will be from 6 to 8 in the evening, 6 p.m. to 8 p.m. And it should be okay for all. If there is any problem, let me know. Take care. Good night. Bye-bye.
Thank you, sir.
Bye, sir.
Thank you,
Thank
sir.
you.
Bye.
Thank you, sir.
Bye.